Yeah, Jalaj. Jalaj, so when previous, I think last class. Okay, you are showing the scripts, right? So in that you have mentioned that you'll be what is it? Unloading the data, right? So for that unloading, we'll be writing the specific query and passing and selecting the list of tables, right? So my question is, right? We won't call the entire table, right? It will be based upon some partition, right? Or how it will be in real time.
So actually, it's just going to, it's based on query. Yeah.
Hmm. No, I understand the query. See, suppose you said that once we done with the table will be blank, right? There will be no records in the tables. So suppose I have STD tables. I don't want to touch the delete records or inactive records. I just need to STD on latest partitions only. So I'll be writing the query, right? To select star from where records is equal to active. So I'll be fetching only those records, right? So if that table, you say that a table gets truncated.
No, see. Sorry. Yeah. So I'm saying if you see this thing, I think we are getting confused here. Let's see the code actually. So this is where we have that SCD part. So this is the query. Okay, I'm saying select
Yeah.
star from a particular table.
Hmm.
Okay. So if you wish to only get the specific records, you can do so.
Hmm. No, I understand that thing. So I'm asking you, so if I update this one, right? I have the function unload data redshift. So I'm running this query, right? Suppose there are multiple records. I'm just putting the active records alone I'm taking. Okay. Suppose that just y is equal to y. So once I run this unload data redshift, right? What will happen? The complete table will be move away,
So
right?
whatever you are going to write in the select statement, that is only going to select it and unload it.
Oh, okay. Okay, got it. So that records will be removed from redshift. Or it will
No,
be only loaded to S3.
it is copied into that S3. It is not
Okay.
unremoved. It is only copied there.
Okay. Basically, unload means it's just copying the particular query result to S3 bucket. That's all.
Yes, yes.
Okay, cool. Yeah, that's all.
Okay. And have you gone to the previous class?
Yeah, this scenario comes out of previous class only actually. Yeah.
Okay.
And also you said in last class you said right like an ID should be captured. It should be within 1 minute. So is it in real time that they'll be capturing the same way only? Like it should be completed within 1 minute.
No, I never said 1 minute time. I am saying it might run for 5 minutes, 10 minutes, or 1 minute also. But your
Okay.
code is going to start from this point onwards. Okay.
Hmm.
So you have to make sure that your function is looping around here. So it is waiting for the query to be completed.
Okay. Also, if my Redshift job fails, my Glue job will not fail. It will keep on running only.
It depends on this thing. Okay. It
Okay.
depends on like if you go on the unloaded Redshift. If you see this thing here, when my query is failed, I'm raising an exception in the code as well.
Hmm.
Okay. So this is going to fail my glue code as well.
Yeah, you're mentioning this. That's why I got this doubt. So I thought, okay, if SQL comes means it will be exiting and coming out, right? But in that meeting, you said specifically that since that query is getting failed, I'm making my glue job also getting failed.
Yes, yes, because there's no point of continuing with the glue job.
Okay, so that's what. Since the Redshift get fails, then also the glue job will be running.
No. If Redshift fails, you are failing your query intentionally, and you are failing your glue job intentionally here.
Okay.
This is what this selected line of code is doing.
Okay. So do we need to write it specifically or it will
Yes, you
automatically run?
have to. If you remove this line number 68, if
Okay.
your query fails, still your glue job is going to try to complete itself. Eventually, it's going to fail. Okay,
Mhm.
because it will not find any data there. It will not find any data frame to be created there. Eventually, it will fail, but it is not a right way of doing such things.
Okay.
Okay, so we only have one person. Let's just wait 1 or 2 minutes more.
Yeah, sure.
So let's get started. So let's say this is the data that we have, this is actually data that we have loaded there. And let's say in this data, let's actually modify this here. Airbnb. Let's do it like this, or actually remove the sheet. Let's say in this data, I add few more entries. Okay, I add this, and let's say something. Let's say one more, and some random values. I'll pick it up. Okay, so we have two new records. Okay, and let's pick one of the existing record. Let's take these two records, paste them. Let's say like these two records. I will say instead of key revenue, I will say key revenue updated. That means value I'm modifying. Okay, for these two records. And let's say two records I remove. Okay, so I'm going to pick these two records and remove them. So this is the file. Let's say we update on the day 2. Okay, Now you can have variety of cases. Okay, and yes, one more. I mean, now we can have actually variety of cases. Either we can have a file like this where every day's updates are getting appended and you're processing that file like we are doing right now. Or you might also only have the changed file in a changed record in a different file. Then your approach will be slightly different. Okay. And also what I'm saying, the way we are solving SCD2 here is not only, I mean, see, there can be 100 other ways to solve the same problem in a programming languages. And I'm not claiming that this is the best way. I am just saying that this is the way that we used in a real time in a project. Okay. So let's continue with from here. We have gone to the if condition. Now, obviously, our count is not going to be 0. It is going to be 1 because we are trying to take 1. Eventually, we have the count of 1499 in our Redshift table. Okay. So now we have to identify, I mean, as this is not our database, now we have to write our code smartly to identify the newly added records, deleted records, and updated records. Okay. So to achieve that process, what I'm doing here is, I mean, my code will come in the else part only in the day when it's going to be in the if part. On all the other days, it is going to be in the else part. Now I am saying we have found the data in previous folder and we're going to run in SCD and loading the data. Okay. To find the new records, okay, I'm finding the new records which are added newly in the source. To find these records, what I am doing, I am using source data frame as my left table, joining it with the previous data frame, that is the data coming from Redshift. Okay. I am joining it based on the listing ID. This is my listing ID. Okay, I'm considering it as a primary key, joining it based on the listing ID, and my join type is left anti. So if you do not know what is left anti join, so let's say we have ID column here in the left table and we have ID column here in the right table, and you have these IDs. And in your right table, let's say you have these IDs. So when you apply left anti, you will get in the output 1 and 5. Basically, you will get the records which are not present in the right table. Now, in our case, right table is Redshift and left table is your source data. If I do so, I mean, if there are any new entries in the source, those are not present in Redshift. We will get these entries in our output with the help of left anti join. Okay. So once we get this and see the result of this join, I am not modifying my original data frame. Okay. I am creating a new Spark data frame called new DF. New DF basically means in this data frame, we will have the records which came newly into the source. Okay. Then same process using monotonically increasing ID, we are generating surrogate key. Okay. And we are using the app.row number and over our Windows spec, but this selected part of code is going to give you 1. Okay. The selected part of code is going to give you 1, and we do not want 1. We want 1500 because we already know that yesterday we have loaded 1499 records into our Redshift table. So what we want 1500. So to make sure, so what we have to do is, I mean, logic is to get the maximum key already present in your Redshift. Okay. And as we know that Redshift's complete data we have in our previous data frame. Okay. So I am simply using the aggregate function, getting the surrogate key and collecting it into a string variable. If you do not use the collect, you will get a data frame here. Okay. But I want an integer variable, not a string variable. I want an integer variable. That's why I'm saying collect operation, collecting first row, first column. Okay. And I'll get my max key. Okay. This is the way we can get the maximum max key present in our Redshift table and simply adding that into our row number. So this is going to give me 1. Max key is 1499 and result we are going to get 1500 in our output. So our surrogate key for this execution for new records is going to get started from 1500 in our case. Okay. Then we have similar things. We have date, we have active indicator as Y, because these are new records. Hence, active indicator has to be Y only. Okay. So let me know if you have any doubt here till here. Okay. So I assume that we have no questions still here. Okay. Next part of code is doing the same process to identify the deleted records. Okay. What we are doing here is simply we have turned our tables. Okay. So let's say we have 2, 3, 4, but 2 is actually deleted from here. So now if I do left NT, okay, this time I will have considered this table as a left table, and this will be right table. So if I again do left NT on my primary key column, what I'm going to get, I am going to get 2. Okay, this is my new, this is my deleted. Okay, I am going to get 2 in the output. Why? Because 2 is the only primary that is present in your left table, but it is not present in the right table. Okay, so if you check my code, this time my left table is previous DF. I am joining it with source DF. Joining condition is eventually same, and join type is left NT. Okay. And then we will get deleted DF. Okay, so in this data frame, I will have the records which have got deleted from the source files. Okay, as these records are deleted records, I will mark their active indicator as N. I will update their load time, and that's all for deleted records. Okay, I'll show the deleted records, like which records have been deleted from our source files. Okay, now is it clear till here? Newly created records and the deleted records.
Yes, deleting.
Okay, I assume that it is clear. Is that we have modified our deleted DF. Okay, we have got new DF and we have got deleted DF, but still in our previous DF. Okay, still in our previous DF which we have downloaded from the Redshift, we still have these records. Let's say we have got 2 records here, those have deleted. For those 2 records, still my entry is going to be Y in my previous DF. Okay. So what I have to do is I have to remove those deleted IDs from the Redshift. Okay. So I have to remove those deleted IDs from the Redshift data frame. Okay. See, when I say Redshift, I'm not going on to Redshift cluster and deleting it from the table. I am simply removing those two IDs from my previous data frame. So how I do this? I again take my previous data frame. I join it with deleted data frame. Okay. So what is going to happen here? What is going to happen here? Let's remove. Let's create one more example. So in my left, I have previous DF that is from Redshift. In my right, I have deleted identified records. Okay. Okay. So let's say I have multiple records here. Okay. And let's say I have identified two of them that are not present in the source. Okay. This I have identified using the here. This I identified here only. Okay. So now if I do left NT, what I will get, these two records will match and I'll get these records in my output. That means the deleted records will now be removed from the previous TF. See, if you see this clearly, what left entities join is doing. Actually, what left join does, left join gives you the rows which are matching with the left, which left join is going to give you all the rows from the left table, whether those are matching or not. But left end is going to give you only the rows from your left table which are not matching with your right table. Okay, that means these are the rows that you will get. So using the same logic, we are removing those deleted. See, this time my data frame is deleted DF. It is not source DF. OK, and in this deleted DF, I'll have only two records which I've identified here in these three lines. In this line, actually, eventually in this line, I have identified that. Hence, I can remove those records from my previous data frame. So now I have three data frames. New data frame contains new records. My deleted data frame contains removed records but with entry as and my previous data frame contains all the records but not the deleted records. Okay, so I'll again take a pause here because it might be confusing, and if you have any questions, do let me know. Is it clear?
Yeah, I'm good, sir.
Okay. Okay. So now we have identified our new records correctly. We have handled our deleted records as well. Now things come up to updated records. Okay. That process starts from line number 145. So first we check. Okay. First we check which records might be updated. Okay. First we check which records might be updated. Now, what is the logic of update check? Okay, first we have to basically identify. If I open a notepad, eventually first we have to identify records are common in both the tables. Okay, source and target. Correct? their columns values. If source has different value than target, pull the value from the source and mark target tables record as history record. This process is clear? I mean, this is going to be the logic for the updation part. First, we have to check which records are present in both the places. Then which records have different values. And if something has different in source, get the latest value from the source and mark the same row as history record or deprecated record in the target table. This is the logic for that. So how we can write this logic into PySpark? We have to identify which records could be updated. Okay. So for that, we have to do join with previous data frame to our source data frame. And this time we are joining inner join. Okay. And joining column is again same listing ID. That basically means if there are listing IDs present in both the places, like some listing IDs that are present in both the places, like source as well and target as well, we have identified those listing IDs here. Okay. And I'm calling the data frame as update check data frame. Now what is going to happen? Okay, now what is going to happen? This join is going to cause one issue. Okay, so let's say we have column A and column B in our left table, and same we have column A and column B in our right table. That is true for our case. Okay. Now what is going to happen if you do a join, inner join on this, you will get A, B, you will get 4 columns in your output. Okay. But when you say select A, okay, when you say select A, or when you try to get a column, it is going to throw you error ambiguous column reference. Okay. It is going to say which A you want to get. I am not sure. Okay, so there are two ways to solve this thing. Either you can use a syntax something like this. Not this one. Let me open that. D drive. Just a second, I'll find that code for you. This is the one here. This is the one I need to get it. So if you see, check this thing. I have given you an example in the classes. Something like this you can say. Okay, you will say inner join, and you will say what you want to select. You can say select from countries TF take name and alias it as country name, from regions TF take name and alias it as region name. So you can use either this way, okay, or you can use this way. Where what I do, I rename my column from price to source price, and we full to source, and I mean basically I'm clearly indicating which is my source, what are the columns coming from the source data frame and what are the columns coming from the target data frame. Okay, so before doing inner join, I'm renaming my columns. Then I do inner join. So basically I'm going to get, instead of AB, I will have underscore A, I mean source A and I'm going to get, okay, because I have already renamed these here. Okay. Now, once I do join, this join is going to give me only the records, as I mentioned, which are for which listing ID is present in both the places. Okay. Once I do this, I select the columns from the target. Okay. I select the columns from the, I select the columns from the source. I select my listing ID, I select my source price, I select my source NB full. I mean, I basically select the source column because source has the latest information. That's why I select the source columns. Once I do this, okay, again I rename my columns as back to normal. I mean, this is a bit, I have made it a bit complex here. You can simply use the syntax that I have shown to you and make it simple. Okay. So basically, in this part, we are just only useful information is this update check data frame that has the listing IDs which are present in both the places. Okay. And we have also pulled the latest information from the source in those update check data frame. Now what we have to do is we will use this update check data frame as a left table and we will join it with the previous data frame. Okay, that is our Redshift data frame. Again, my join type is left empty. This time I'm saying if the combination of price and NB full, that means these two columns. Okay, these two columns. If the combination, like let's say for example, these two columns, I have it here. Okay, let's do Control Z instead of cut. Let's use copy. And same way, I will take these columns from here. What are the columns? Yeah, so I mean, this is one part. This is what we have on source, and this is what we have on Redshift. We do not have this updated, keyword there. Okay. So what is going to happen now? I'm doing left anti on this combination, like this combination. So obviously there's a difference for these two columns. There's a difference. Okay. So what is going to happen? Out of those records which are present in both source and target, only those records which have different values in the source. Okay. Update check is nothing but a source information. It is having source columns. Only that rows are going to be picked up in the updated DF. In our case, only 2 rows. Okay, these 2 rows will be present in the updated data frame. Okay. So I'll again actually pause here before I move ahead. If you have any questions here.
Jalaj, where are you checking the changes in columns?
Come again?
No, you mentioned right. You'll be checking whether any change in source to target. So here, where you check, you are joining with that key, but where you're checking that thing?
See here. See what this inner join is going to give you. All these listing IDs, okay, because these are present in Redshift as well and source as well. Correct?
Yeah, right.
So we'll have these listing IDs present in updated check data frame. Correct? Now on line number 155, I am saying if my price column and NB full columns values are not matching with my previous data frame. This time I'm using left anti. It is not an inner join. This time I'm using left anti. Same logic to distinguish the record.
Okay.
If the values are not matching for these two columns, I will get those results in updated DF. For our case, only 2 records. These 2 records. Okay.
Okay.
Let me just remove it. Is it clear to you as well, Ashwarya?
Yeah, Jalaj.
Okay. Now we have to give, what we have to, give the surrogate key to these updated columns as well, correct? So for that, what I'm going to do, I'm going to get the count of new DF, okay? That how many records we got in this current execution in the new data frame. So for that, for us, it is 2 records. So what is going to happen? 1499 plus 2, that is 1501. And after that, I'm going to create my row numbers on these 2 records. That means 1502 and 1503 will be the surrogate key for these 2 records. Okay. That means we will add the max key from the previous table and new DF count from the new DF data frame from the current execution, and then row number over the monotonically increasing ID. Okay. And rest columns, rest things are same, as these are my active, like new columns are the active columns. So I'm going to say active indicator as Y, and load time I'm going to modify it here. Okay. This 165, I am simply selecting the columns in the correct sequence. So all at the end, I'm going to append these records. So I just want correct sequence in all the places, like in my new data frame, in my delete data frame, and in my update data frame. That's why I'm simply selecting them again in the correct sequence. Okay. Now there's only one thing pending. It's still in my previous data frame. Okay, still in my previous data frame, I will have those records as a via entry. Okay, like here I have modified my updated records to via entry, but still their old versions are having via entry. I have to mark them as an entry. So for that, again, I'm going to repeat the kind of same process. Renaming columns before doing inner join. Again, I'm repeating. You can use the other syntax that I've just shown to you. And whatever the records that are present in previous data frame, and those are also present in updated DFN. Okay, it is nothing but the records. See, updated DF and updated DFN are same data frame. Like they will have the 2 records itself. Just data frame name I have modified here for the purpose of use, and I am doing an inner join. Okay, and all I am modifying my previous data frame. Okay, so what it is going to do, it will give you only 2 records now in previous data frame that you have to mark as n, and again you will modify the load time here. And see, as I have only load time column, if you have a start time and end time, you will modify both the columns here, here only. Okay, and at the end I have to identify records that came again but didn't get updated. Okay, that didn't get updated. So remember, in our update check DF, we have all those records. Only 2 we have selected for our updated DF. But in our updated check DF, we have all those records. And if we minus those records which got captured in the update DF, we will get all the records. Those have not been updated. Okay. And at the finally end, I am doing new data frame, unioning with updated and unioning with deleted DF, updated DF, and no updates. And I'm finally getting my final data frame. I know this is very confusing for the first time, but today I'm going to pass on the code to you, so you can go through the recordings and revisit this code and try to execute this code and try to once this course is done, try to modify this code as well. If you can master this code now, you can write down any SCD logics. Maybe you can optimize this further. So I'll take a pause here if you have any questions. Do we have questions? Okay, before that, let me go ahead and start my cluster. And guys, one thing, we are right now having very, huge openings in the data engineering field. If you can prepare early now, you will get good hikes. Like right now, companies are ready to offer 50, 60, 70% hikes as well. So just be ready, okay? Do not wait. And start giving interviews. Like we have covered almost all the topics, just the final project is going on. So if you start the, giving the interviews right now, maybe after 2-3 interviews, you'll be in a good shape to, clear the interviews. And if you want, we can have a mock interview maybe day after tomorrow, like Friday actually. Tomorrow we are going to finish the project. And day after tomorrow, we can have the, this thing, and yes, EMR is pending. So maybe, Saturday we can connect for interviews. Friday we'll cover the EMR and yeah. So yes, I'm again back on my code screen. If you have any question, any doubt, please let me know.
Jalaj, for all the Redshift, right? So by default, we need to write this many scripts lines for our recipe type 2. And
this is what I mentioned. This is one of the way of solving this SCD type 2 on Redshift.
Okay.
When we are on AWS CRUD, there can be multiple other ways. You can use Spark connector directly, and then you might not have to do all these steps. You can use simple update logic as well. But in that case, your writes and reads are going to be a bit, bit more heavy on. They will become actually with heavy operations.
Okay, so you're directly updating on Redshift immediately.
Yeah, and this, it seems bit meshy in the start, but if you do 2 or 3 rounds of this code, it will be easily understandable.
So we'll be seeing in Snowflake also SCD type 2 or
SCD type is always there, like whether you are on databases, Redshift, or anywhere.
no, I'm asking, will we seeing that in Snowflake?
No, actually, we are not covering that thing right now.
Okay. But in Snowflake, if you write our code will be very minimal, right?
See, again, there are 2 ways. You can use the same approach as well. As we discussed yesterday, you can use the same approach as well. Eventually, we are going to write all these things on the S3 only, correct?
Right.
So you can do it there as well. Okay, you can use the same approach, or you can connect with the Snowflake directly and update the data frames, or you can simply push the data into some staging table on Snowflake, and then you can write the STD logic.
Yeah, that's what I'm asking. So suppose I'm creating an update script will be working in Snowflake, right?
Yes, you can do that. So I think I have that example. Yeah, it is SCD1 logic here is there. Okay, so this file is doing SCD1. You can modify it to SCD2, and you can see I am deleting using the sales staging table. Okay.
Yeah.
So in this approach, what you have to do is you have to just transform your data and send it to Redshift table or Snowflake table, and then you can write stored procedures there to do your SCD.
Okay.
Okay. Then obviously we will not have to perform all these steps, but your burden will increase that as and when you complete your glue job, you'll have to trigger your Snowflake procedures or Redshift procedures, and you'll have to again wait there for successful completion. I mean, this is project specific, which one you like or which one you prefer or comfortable with.
Okay.
So actually, let's do it like this. I am going to send you this code now. You can go through this and see. This is, okay. Let me tell you what exactly we are doing in day-to-day work. Okay. Training codes. Clue. Okay. See what we guys used to do. This job will get triggered from the AWS Lambda functions. So from that, you will get the variables here. Okay. This S3 input path will not be hard coded like this. We can also automate this. You will get it in the glues arguments, and it will be, self-generated. Okay. Then same way, table name will also be self-generated. Like what we do based on the folder name of the S3. So our naming conventions were very strict. Okay. So based on the folder name of the S3, we were defining our S3 input path and table name. Okay. So if you can make these two variables dynamic coming from the Lambda functions, then you can make this output path and all the variables dynamic, correct? Once that is done, you can write all your transformations that you want to do on the source here, and all your SCD2 logic is kind of same only. Whether you want SCD1, whether you want SCD2, all your logic is same only. What you have to do is you just have to modify the columns here. Like some source might be joined on listing ID, some source might be joined on some other columns. Those columns you have to modify in this logic, in this framework, and then your SCD will like this is you can use as a framework code, and you can modify it for all the sources. And like that, we were transferring one or two sources every sprint into the production. Sprint was of it was 4 weeks of sprint, 2 weeks of development, 1 week of development, 1 week of dev testing, 1 week of UAT testing, and 1 week for your deployment and validations in the productions. So getting my point, what I was doing in the project for 2 years. Okay, my core was to in 3-4 months we designed this architecture and we defined this architecture and we implemented that. After that, it was kind of a bread and butter for us. Simply use this code and write our transformation logics and just modify this code and move other sources as well to Redshift. And also we had to write some Redshift queries to create the tables, and also some logics were there where we have to combine multiple Redshift tables to create some views. So challenges were there on the SQL side. Now, as you can see, the work is more related on PySpark and SQL. That's why they are going to ask you 70% of questions not from the cloud. Even though they are saying it is a AWS job, they're going to ask you questions based on SQLs and Python and PySpark only. Okay. So you have to, as I think I have already explained this. It is one of the warehouse, one of the programming language, PySpark, and SQL. If you can master these 4 things, cloud now you know more than enough to clear the interviews. Okay, so let's see. My cluster is available. I'll come back here. I'll go on S3. Actually, before that, I'll come here. I'll remove the sheet 2. Okay, now I have my data here. I'll save this file. I think I have saved it in a wrong way. Boom. Okay, let it be. So I'll come back here on S3. I'll go into my source bucket. Airbnb. I'll remove this file. I'm going to upload the latest file. And simply upload this. Once we have uploaded this, I'll come back here. Okay, and I'll open the glue console. And one thing in the glue job, what you have to do is you have to create a job. You have to paste your script there. Okay. Then one more thing that you have to do, you have to come in job details. You have to go in advanced properties. And you have to upload, you have to update the path for your my functions file. Okay. So basically, wherever you are uploading this on the S3 bucket, the same location till the file name you have to mention here in the Python's library path. Only in that case you will be able to import the my functions. Okay. Now I will run this job. And if everything goes fine, let's see how it goes.
Jalaj, in this one, right, in Glue, right, whether we have any place where you can store all the environmental variables. So now we are passing in .py files, right, like S3 path, those stuff. So is there any in live location, like in production, they'll be using?
Yes. Actually, that we have discussed, it is in the job details. You can pass on the variables.
Okay, that only I mean.
It is in the job parameters.
Yeah, I've seen this one. Just asking, like in a shell script for run, right, we'll be passing like environment source is equal to particular environment. From that source, it'll be passing the file name. So
Yes.
here it's only we can use this as a parameter file, right? We don't have any other thing. Okay.
Only this is the parameter file you can use. So on CloudWatch, let's see how it goes. How the West. So you can see length is now 1. We are running the SCD loads. In a few more seconds, we should be able to see the data, and you can see this is the data frame for your newly added records. Let's see, we have 2 records, all 8s and all 9s. Okay. And then we have deleted records. 2 records we deleted. Those have been captured here with correct active indicator. Okay. Then we have updated DF. 2 records in our updated data frame. Correct. And then we have which not got updated, multiple records, obviously. Only 20 of them, only 10 of them I am showing here. And this is the final count, 1503. And then we have the final output here. Okay. And this final output, we are again truncating and loading into our Redshift table. Now data load for the Redshift is finished. And if you see the Redshift now, let's connect with a query editor. And if I do it here, this details. Okay, now we have total rows 1503. So yes, if you have any questions. I mean, I'll leave you on the CloudWatch page if you have any questions.
We'll be having only active indicator Y, right? We don't have any end records. Or we have end records.
Definitely we'll have now 2 records. If where I'll say Y will array where active flag equals to n. execute this query. Okay, what is the column name? Let's start. I think it's
FLG.
I have misspelled the active IND only. Active IND. And
also, Dilaj, just check now. Currently, we deleted the complete table, right? Or we just reloaded it?
we deleted the table and reloaded it.
Reloaded, right? So,
again, see that also you can modify as per your requirement, as per your optimizations. So we have 4 records, 2 we have deleted and 2 we have modified.
okay. Oh, Jalaj, can you share some AWS entry questions, like any materials you have, like for the up performance, securities, or which bucket to choose? Those kind of questions will be here, right? So you have any materials kind of things for that?
Not very handy with me right now.
Okay.
I mean, that is something I'm going to capture from internet also. So if you want, you can also try that.
Yeah.
So I can,
And also any dumps you have for certification?
certification terms, it is this website you can use. See, if you type, let's say you want to do for data analytics.
Yeah. Is it we can clear it easily, or how it is?
Tough one. I mean, see, there are 2 ways, okay? Analytics, okay? There are 2 ways of clearing it. One is you understand all those things and then you clear it, okay? An easy way out is if you just want certification, you can say AWS certified. Say all same dumps. Just go through this website, exam topics, okay?
Okay.
You can see 70% questions comes from here.
Oh, okay. So you didn't give any exam, right?
No, I have cleared this one in 2021.
Okay.
See, as I written on the WhatsApp group now. See, if you are like, I was at that time I was in Accenture, so managers and all those praised me. They shared me a 5,000 voucher. Quarter of the employee of the month or employee of the quarter awards. They considered me for the promotion. That's all. This is not, and this is also going to help you. Easy CV selections. That's all. It is not going to help you in your interviews.
Yeah, right. But some companies, right, is asking nowadays for cloud solution mandatory, like Fidelity and all, right? They're asking for mandatory certifications.
I haven't gone through those kind of things. So if you go through, I mean, one thing with this website is, their questions are correct. Their options are also same. But if you click on review solutions, it might, say D, but you have to go in discussion board. And everybody is saying say C is the answer. So discussion is the correct place.
Okay.
And this is going to be headache for you because you might have to read all the comments here.
Yeah.
And if you can see, like this guy is eventually explaining that, so if you can understand this part, that is what's going to help you. For sure the answers are wrong.
Okay. I
mean, only in few cases it is right, but for sure answers are wrong. We have covered most of the certification, only not the security and the quick site. So from quick site you get 1 or 2 questions, and from security you might expect 5 to 6 questions. Let's find some question. I mean, they are asking for a payment now. Earlier it was free. Maybe got very famous. Yeah, like this one. I think you should be able to solve this one. Hmm. So obviously, as you can see, all the options are actually correct. But which one is the most perfect one? You have to choose that.
Using the AWS glue job, we can insert the data into MySQL also.
Yeah, anywhere you can insert. I'm doubting this answer because nowhere they have mentioned MySQL. It's all Redshift. So I think this one can also help you in Apache Spark itself. Or the correct way would have been using the job bookmarks. But this is not the correct answer. I'm not sure why discussion is saying correct answer B. Okay, A, B is wrong. C is using Spark, not destination DB. So it's A. Okay, A is the correct answer. What is A saying? Staging table, add SQL commands to replace existing rows in the main table as post questions in the dynamic frame. I mean, some kind of SQL commands we have to add in the dynamic frame writer class. So we are doing the PySpark way. You can do it the SQL. So eventually in the glue script only we have to handle this condition. Because MySQL is something you are introducing third thing. We already have S3, Redshift, and Glue, and you cannot, you do not want any third-party tools again. And see, this is how this certification is actually a bit tough. All the answers actually are eventually correct. You can use all those 4 ways, which is the most optimized way. And this will need a lot of practice actually and experience as well. Okay, and yeah, remember to pause your cluster. Where is my cluster? Yeah, so if you have any questions, you can ask those, Ashwarya and Karthik. Otherwise, we'll meet tomorrow.
Yeah.
We'll see.
You'll be sharing the thing, right?
Maybe. Come again?
No, you'll be sharing the codes, right, today, or?
I have already shared it. Let me just re-verify. You have already shared the code.
Okay, I can show you. And also one more challenge. So how you building this all this Python .py to a single file? Like we write in Scala code. So we use map and build and create as a jar. So we'll write 100 or how many pages are there will be created as a single jar. So this .py files, right? So how you will build actually?
No, I'm not doing anything. I'm simply writing them and pasting them onto the glue screen. That's all.
Okay, I'll check. So how will be called? So you would just be importing my function. That's all in that Park job.
Yes, yes.
And also one more thing, in Spark Submit, right? We'll be writing any Spark Submit jobs. I think in Glue it's not possible, but in EM,
it's not on here.
It's not here at all.
Yeah, actually run on a Spark Submit is actually the same thing. You are seeing run here.
Okay. Yeah, that's all.
Okay. Yeah. Thanks, Karthik. Bye bye.
Yeah, thanks, sir. Bye.